Good day, ladies and gents. My name is Latago, and welcome to my revision series. Today we are continuing with antiderivatives. So let's get to it. Okay, so we're gonna have to first look at the table of rules. And so the first rule is a basic rule. It says C f of x, the antiderivative of that. I'm just gonna say antiderivative. Okay, I'm gonna write it in full. Is C f of x. So basically, if there's a constant, right, multiplying the function that you are anti-deriving, then you keep the constant the same and you focus on the function. You keep the constant on the side, focus on the function. So yeah, that's what I like about maths. Sometimes it teaches you focus. Put distractions on the side, just focus. It's a cool thing. So now for number 2, we'll have f of x plus g of x, right? Then the antiderivative of that would be uppercase f of x plus uppercase g of x. So I think that's basic enough for us to understand. Okay, so number 3 is x is the exponent of n. N is not equals to -1. Like, this is very important. This is very important. N plus 1 all over n plus 1. So it's x to the exponent of n plus 1 all over n plus 1 when we antiderive it. So this part is very important. When n is equals to -1, we do something differently. So it's as follows. So number 4, 1 over x, that means n is equals to -1, is as follows. We antiderive it this way. The antiderivative of that will be equals to ln absolute value x. Why absolute value? Because ln on the negative side does not exist. So that is that. Then positive x. So we're keeping the x variable positive. And for 5, we have e to the exponent of x, and the antiderivative of that will be e to the x. I like e to the x because it never changes. And you don't have to think when integrating. Oh, spoiler alert. When you deriving e to the x, you don't have to think 10 times, twice, 300 times. Nah, it's still the same. Okay, and then number 6, b to the x, the antiderivative of it is b to the x all over ln b. So you know how when we derive an exponent, an exponential function, we get something like this. You keep it the same and then multiply by then b, and multiply by the derivative of the exponent, which is 1 in this case. So it's basically like this. So the opposite of that derivation is the anti-derivation. So okay, let me just write it in proper notation. So when we're doing this, what we'll have is this, right? So the anti-derivation of this, which is the integral, but we'll get to do that later. So the antiderivative of this with respect to x is equals to antiderivative of this with respect to x. So since ln b, this is like it's like this. The answer is equals to x. So deriving and anti-deriving, those processes cancel each other out. In a way, so we have bx, so ln b is not in terms of x, and then we have this dx divided by ln b divided by ln b. Okay, so this will be equals to this. So now, I know I'm wasting a lot of time on this, but it's very important information. Sine x, antiderivative of that is cos, negative cos x. Right, because when we're deriving cos, we get negative sine. So that's the case. And then 8 cos x, the antiderivative of that is just sine x. And then 9 secant squared x, the antiderivative of that is just tan x. And 10 secant x tan x, the antiderivative of that is just simply secant x. Right? And then 11, you remember the inverse trigonometric functions, so that's that. So 1 all over root 1 minus x squared, the antiderivative of that is just arc sine x. And 12 is 1 all over 1 plus x squared, the antiderivative of that is tan x, arctan x. And then 13 is cosh, which is hyperbolic cosine x. The antiderivative of that is going to be sa, which is hyperbolic sine x. I remember I'm a UJ student, so you need use cosh and sa and stuff. And then hyperbolic sine x, which is sa x. Antiderivative of that is cosh x, hyperbolic cosine x. Right, so this is the table of rules. But if you're proficient at deriving, you do not need this. If you know your derivatives, you don't need this. This is yeah. But if you still need a bit of work with your derivatives, you need this table. The only part I think you need is this part. This is very important. We need to always be remembering this and this. These two are of great importance. But the rest, if you know your derivatives, you should know. So, yeah. But mistakes are possible. I'm not saying, hey, be a complete genius. Just saying, it's just know these. These are very important. Very important. Very important. So now, let's get to examples. So example 1 says find the most general antiderivative of the following, which is g of x is equals to 2 cos x minus 3 all over 1 minus x squared plus 1 plus 3 all over root x. So most general antiderivative, first I just like doing this when I start, so I tell the marker that this is what I know it to be. Right, and then antiderive. So we know that we could put the constant here on the side, and the derivative, the antiderivative of cos is sine. Why? Because when I derive sine, I get cos, right? So it's sine x. And then put the constant on the side. And then 1 over root 1 minus x squared. The antiderivative of that is arc sine x. Right? And then with this one, constant on the side, I just say negative 1 over 2 x to the negative 1 over 2 plus 1, which is 2 over 2, all over negative 1 over 2 plus 2 over 2. So plus c, since it's the most general derivative, antiderivative. So g of x is g of x is thus equals to 2 sine x, right, minus 3 arcsine of x plus 3 x root x all over 1 over 2. So it basically looks as follows: g of x is equals to 2 sine x minus 3 arcsine x plus 6 root x plus c. Don't forget the c. C is most important. That's what the markers wanna see. Okay. Other question says also find the most general antiderivative of the following, which is f of x is equals to 2 to the x plus 4 sa hyperbolic sine x. Right, so what we will get here, firstly, notations. Right, and then what we will be getting here is the following. So we remember when we were anti-deriving b's to x, so the antiderivative of that was bx over ln b, right? So this is the same case with 2 to the x, so it's gonna be 2x all over ln 2, and then plus, take the constant to the side, and then sa hyperbolic sine x, the antiderivative of it is hyperbolic cosine x plus c. So this is our solution. If you wanna try these things out on your own, you could pause the video, do them, and then check your solution with mine. Then 3 says find the most general antiderivative of the following: r of theta, okay, is equals to secant theta. Why do I keep writing the rotational coordinate? Tan theta, yeah, minus 2 e theta. It doesn't matter. 2e theta. Right? So now you need to find this. Well, you know that r prime of theta is equals to r of theta, which is equals to secant theta tan theta minus 2e theta to the theta. That's so r theta is thus equals to, remember when we're deriving secant, we get secant tan, right? So the antiderivative of secant tan is secant, so you get secant theta, and then plus minus 2 constant to the side. The antiderivative of e to the theta is e to the theta plus c. So this is the most general antiderivative. That is our answer. Same confidence. And then question 4. Question 4 says, so it says find the antiderivative of f of x is equals to 2x with c is equals to 3. So basically f prime, uppercase f prime of x is equals to lowercase f of x, which is equals to 2x. Right? So uppercase f of x is equals to 2x squared over 2 plus c. So which is equals to x squared plus c, where c is equals to 3. So therefore f of x is equals to x squared plus 3. Then question 5. We have find f, lowercase f, if f prime prime of x is equals to 12x squared plus 6x minus 4 with f of 0 is equals to 4 and f of 1 is equals to 1. Now this one is quite interesting. For you, it is interesting. So let's find f of x. So f prime prime of x is equals to 12x squared plus 6x minus 4. Remember, here the notation is okay, right? Don't criticize it. So f prime of x will be equals to 12x cubed all over 3 plus 6x squared all over 2 minus 4x plus c. So this is the first job we had to do. F prime of x is equals to 4x cubed plus 3x squared minus 4x plus c. And then f of x will thus equals to 4x to the 4th over 4 plus 3x to the 3rd over 3 minus 4x squared over 2 plus cx plus another constant, let's say a. Calling it a. So thus f of x is equals to x to the 4th plus x to the 3rd minus 2x squared plus cx plus a. Right, so this is what we have. So we know that f of 0 is equals to 4, right? 4, right? We were given in the question. So 0 to the 4th plus 0 to the 3rd minus 0 to the 2nd plus c0 plus a is equals to 4. So all these zeros are 0, so a is equals to 4, right? So we have f of x is equals to x to the 4th plus x to the cube minus 2x squared plus cx plus 4. Right? And now we're looking for c. So f of 1 is equals to 1. So 1 to the 4th plus 1 to the cubed minus 2 1 squared plus c 1 plus 4 is equals to 1. So 1 to the 4th is 1 plus 1 to the cubed, which is 1, that's 2, minus 2 times 1 is 2, so that's 0, plus c times 1 is c plus 4, so we have c is equals to 1 minus 4, which c is equals to minus 3. So therefore, f of x is equals to x to the 4th plus x to the 3rd minus 2x squared minus 3x plus 4. So this is our f of x. And that was question 5. And question 6 says the following. Question 6 is, find f if f prime prime of t is equals to 2t 1 over 3 minus cos t with f prime of t, f prime of 0, I meant to say, equaling to negative 2. And f of 0 is 1. F of 0 is equals to 1. So let's see. So we have f prime prime of t is equals to 2t 1 over 3 minus cos t. So f prime of t is equals to, we have 2, keep it to the side, t 1 over 3 plus 3 over 3 all over, right? All over 4 over 3 minus, now what's the antiderivative of cos? It's sine. Why are we saying it's sine? Well, if I derive sine, I get a positive cos. So going back will give me a sine, a positive sine. Because the cos was initially negative, the sine will also be negative. Plus c. So this is plus c. And so let's write this more prettier, make it beautiful. Yeah, t is equals to 2 times t to the 4th over 3 divided by 4 over 3, so times 3 over 4 minus sine t plus c. So now, okay, let's make it prettier. She needs to look beautiful. So c, so 3 over 2 t 4 over 3 minus sine t plus c. And so this is what we have. So we are told that f prime of 0 is equals to minus 2. So what we have is going to be 3 over 2, 0, 4 over 3, which is all over the 0, minus sine 0 plus c is equals to minus 2. So 0 plus c is equals to minus 2, that means c is equals to minus 2. Right. So our f prime of t is given by 3 over 2 t 4 over 3 minus sine t plus minus 2. Now again, antiderivative. So f of x, because remember they said find f, not f prime. So f of t is equals to 3 over 2, the constant to the side, times t 4 over 3 plus 3 over 3 all over 7 over 3. Right? Minus, look at this now. I need to derive cos to get sine, right? But there's a but. If I derive a positive cos, I get a negative sine. So if I derive a negative cos, I will get a positive sine. So in that case, I get negative cos t minus 2t plus, I'm going to say d as our new constant. Right? So f of t will be equals to 3 over 2, right? And it will be divided by 7 over 3, so it's times 3 over 7 times t to the 7th over 3 plus cos t minus 2t plus d. So f of t will be equals to 9 all over 14 t 7 over 3 to the 7 over 3 plus cos t minus 2t plus d. So since they told us that f of 0, so f of 0 is equals to 1, right? So 9 over 14, 0 to the 7th over 3, which is still 0, plus cos 0, which is 1, minus 2, 0, plus d is equals to 1. So 0 plus 1 minus 0 plus d is equals to 1, where d is equals to 0. So therefore, f of t is equals to 9 over 14 t to the 7th over 3 plus cos t minus 2t. So this is our final answer for the day. Antiderivatives. So thank you guys for watching. Good luck on your exams if you are recapping with me, as I'm also writing an exam. And yeah, show no mercy. Show them who you are. But if you're learning this for the first time, thank you for watching. Make sure to like and subscribe. And yeah, let's kill it.